Hi, hello, welcome back, students of grade 11. Welcome back to lecture 3. Already we have completed two lectures. In those two lectures, we have completed few concepts, and in this lecture, you are going to learn two major concepts from chapter motion in a straight line. First concept is related to acceleration and types of acceleration. Second one, deriving equations of motion. Okay, first let us try to understand what is meant by acceleration. Here, consider there is a body which is starting at initial position, or we can call it as initial point. Let us consider A as initial point. And that body is moving in a straight line. Body moves in a straight line. So when body is moving in straight line, already we have discussed in this lecture, previous lectures, when body is going in a straight line, distance is equal to displacement. And rate of change of in the sense in denominator, time will come. Rate of change of distance is nothing but speed. Rate of change of displacement is nothing but velocity. Now, if a body is going in a straight line, distance is equal to displacement and speed also will be equal to velocity. Now, body, it might go with increasing in its speed or decreasing in its speed. Both ways are possible. And if a body is increasing its speed, I mean increasing its velocity, both are same, right? So if a body is going with increasing in its speed or velocity, such type of motion we are calling it as accelerated motion. Accelerated motion. So what is that accelerated or acceleration? Now the concept acceleration is nothing but change in velocity upon time taken. Consider body is starting its journey at A and it went to the point B. A is initial point, B is final point. At initial point, it will have some velocity. We'll call it as initial velocity. Initial velocity. That initial velocity is represented with letter small u, or in your 11th class textbooks or materials, it is represented with the V naught also. So initial velocity with u, in some materials, we can find it as V naught. Both are correct. And at final point, it has some final velocity. Final velocity is represented with the letter small v. Initial velocity with small u, final velocity with small v. Now, at initial point, body might have time t naught, velocity v naught. At final point, body will have, body, it will take time t to reach final point and it reaches with the final velocity v. Now, acceleration. Acceleration is nothing but change in velocity by time taken. So what is change in velocity by time taken? We can take it as acceleration A is equal to change. Whenever you find the word change, so you can go it as final minus initial. So now everything final minus initial. Change in velocity by change in time. So what is final velocity? It is v, minus what is initial velocity? It's u, upon time taken is t. So this is the formula we are using for acceleration. Now what is the SI unit of acceleration? It is meter per second square, or you can write it as meter s to the power of minus 2. Now this is SI unit. SI unit of acceleration. This you should remember. Now acceleration is vector quantity because it has both magnitude as well as direction. Next concept. There are types of acceleration like uniform acceleration, variable acceleration, average acceleration, and instantaneous acceleration. Let us try to see what are these different types of acceleration. Now, let us go with number one, uniform acceleration. When we can tell an object is moving with uniform acceleration, if its velocity changes by equal amounts in equal intervals of time. Okay, consider body is going in a straight line motion, let us take, and this is initial point. Let us consider it as O, means origin. Here we have point A, B, C, D and E. These are the different points. Now from O to A, body is taking some time. Let us consider it as 1 second. Again from A to B, same time, it is taking 1 second. B to C, it is taking 1 second. Same like that in every path, it is taking 1 second. Now body is traveling from O to A, consider with some speed 1 meter per second. Now again, when it is moving from A to B, its speed got increased to 2 meter per second. Now BC distance, it is traveling with 3 meter per second, and here it is traveling with 4 meter per second. So gradually its speed or velocity is increasing in equal intervals of time. A to B, B to C, C to D, D to E, it is taking only 1 second to cover, but it is traveling with the different speeds like 1 meter per second, 2 meter per second, 3 meter per second, etc. Now you see change in velocity. How much it got increased? 1. Again from 2 to 3, how much increase? 1. Again 3 to 4, 1. Like that, if the change in velocity, the velocity changes by equal amounts. So change from this path to this path is increased by 1. Again from this path to this path, it is increased by 1. Like that, gradually if the speed is increasing with equal amounts, such type of acceleration we are calling it as uniform acceleration. Now what is meant by variable acceleration? So second, same concept only we can take like, now consider body is traveling and this point is origin O, A, B, C, D. Same from the first example, from O to A, it is covering 1 second. Again from A to B, it is traveling with the time 1 second. And again from B to C, it is taking only 1 second to cover. C to D also, it is taking time 1 second to cover. Consider body is traveling from O to A with 1 meter per second speed or velocity. From A to B, it is traveling with 4 meter per second velocity. Again from B to C, it is going with 10 meter per second velocity, and C to D, it is going with 2 meter per second velocity. Now you see how much increase is there from 1 to 4, 3 times. Again from 4 to 10, 4 to 10, 6, difference is 6. Again 10 to 2, it is minus 8, isn't it? So it is decreased by 8. It is increased. Here it is increased. So variable acceleration or non-uniform acceleration, you can call. The acceleration of an object is said to be variable acceleration if its velocity changes by unequal amounts in equal intervals of time. Time can never be unequal. Every time time will be equal, but numerator, it can be changed. So if a body is traveling with equal amounts of velocity, if it is increasing with equal amounts, it is called uniform acceleration. If it is going with variable amounts, it is known as variable or non-uniform acceleration. And third concept we have average acceleration. What is that average acceleration? So consider this is the point O, body is starting its journey and it went to A. Now O is initial point, so that it has initial velocity. I mean, you can consider this one as the first point, so that it has velocity v1. And this is the second point or final point, velocity will be v2. At initial point, time will be t1, and final point, time will be t2. Now, what is average acceleration? AVG, average acceleration, is equal to change in its velocity upon change in its time. So A is equal to, what is change in velocity? As I told, change is nothing but final minus initial. Now change in velocity. Final velocity Vf, final velocity minus Vi, initial velocity, upon TF, final time or time at final point, minus initial time. So what we can substitute, A is equal to final velocity is V2 minus initial velocity is v1 upon final time is t2 minus initial time is t1. So the change can be represented with symbol delta. So it is delta v, change in velocity, upon delta t, change in time. This is the formula for average acceleration. Then we have instantaneous acceleration. What we have discussed in lecture 2, instantaneous speed and instantaneous velocity. So instantaneous acceleration. Instantaneous means at given instant of time, at particular time, right? So at particular time, if you are calculating its acceleration, it is instantaneous acceleration. So acceleration is equal to, we know, change in velocity upon change in time. And we are measuring or calculating acceleration instantaneous, means at the particular instant of time, so that we are limiting that time value to 0. If you're limiting time value to 0, it means you are calculating or measuring acceleration at the particular instant. So what you need to do, delta v by delta t, it's nothing but you need to differentiate velocity with respect to time. So this can be written as d by dt of v. So you are differentiating velocity with respect to time. That is nothing but acceleration. We have discussed velocity also, right? Now you see, velocity is nothing but displacement by time. If you want instantaneous, v inst, v instantaneous is nothing but d by dt of x. You are differentiating displacement with respect to time. Now a instant, instantaneous acceleration is nothing but d by dt of v, and we know what is v, d by dt of x. So substitute here, it becomes d by dt. Instead of v, what you can substitute, d by dt of x. Now it becomes, so double differentiation, it becomes d, it is d square x upon dt into dt, it is dt square. So a is equal to dx square by dt square. That's what here we got. That is instantaneous acceleration formula, which will be used in solving numerical problems. So while you are solving numerical problems, this can be used. Okay, now last two concepts related to acceleration, that is positive acceleration and negative acceleration. So what is positive acceleration? If the velocity of an object increases with time, its acceleration is positive. So slowly its speed should increase. For example, uh, what we can take, a train which is leaving from the station. Train which is leaving from the station. Consider here there is a train and it has to leave from the station. For example, it is in Delhi and it has to go to some Gujarat, Lucknow or somewhere. Let us consider. Now, train slowly, what happens? Slowly its speed will increase. It might go in 1 second with 1 meter per second. And again, okay, acceleration we are taking the 1 meter per second square. And second it might go with 2 meter per second square. And third second it might go with 4 meter per second square, then 10 meter per second square. So gradually its acceleration is increasing time to time. So if acceleration is increased time to time, the step of acceleration we are calling it as positive acceleration. And what is negative acceleration? If the velocity is decreasing with time, it is known as negative. Example, same train arriving the station, arriving to the station. Now you are reaching your destination and consider this is the station. From here train is coming. It comes with greater speed, maybe 50 kilometer per hour, something velocity speed. Slowly it becomes 40, then 30, 20, then slowly 10, 9, 8, 7. It comes to 0. So slowly its speed or velocity is decreasing. So if a speed or velocity increasing, we'll call it as acceleration is also increased, that is known as positive acceleration. If speed or velocity is decreasing, automatically acceleration will decrease. We are calling it as negative acceleration, or it is known as retardation. And another name also we have, that is deceleration. We can call it as negative acceleration. deacceleration, retardation, deceleration. These 2 to 3 names or terminologies we can use. This is about acceleration. I hope you have understood. Then let us going to see equations of motion we need to derive. So already in your grade 9, when you are in class 9, you have derived equations of motion. Now in this 11th class, you are going to derive equations of motion, but there are different methods to derive. So what are those different methods? First method is deriving algebraic method. Algebraic method. Second one, graphical method. Third one, calculus. So these are the three different ways to derive equations of motion. In this video, now we are going to see deriving equations of motion using algebraic method. And in next lecture, lecture 4, we will see graphical as well as calculus. Okay, let us revise what are the equations of motion you know. First one, V is equal to U plus AT. Second one, S is equal to ut plus half at square. Number 3, v square minus u square is equal to 2 into a into s. Right. Now, in some textbooks or in some materials, there are few notations you should understand. As I said, u, initial velocity, it can be represented with v naught also. Final velocity, v is with v. Okay, acceleration will be as usual, that is a. Time is as usual, t. And while coming to displacement, yes, can be represented with x. So these are the two differences you need to remember while you are solving. So don't get confused. After watching this video, you can refer some different types of textbooks or materials where v naught will be represented. V naught nothing but initial velocity u, x is nothing but displacement s. Okay, so for easy understanding, let me take this only u, v, a, t, s, etc. Okay, now let us try to solve or derive first equation of motion. So to derive first equation of motion, that is number 1, v is equal to u plus at, or you can write this one as v is equal to v naught plus at. Both are same, isn't it? Okay, now we know formula acceleration. Acceleration is nothing but change in velocity upon time taken. Okay, how we can represent this? Acceleration is a change in velocity. Change in velocity is nothing but final minus initial, final velocity minus initial velocity upon time taken is t. Now t is dividing the side. If it goes that side, it will multiply. A t is nothing but v minus u. Now you see this u is having negative sign. If it goes that side, it will have positive sign. So at will be like this, minus u. If it goes that side, it becomes plus u. So u plus, which is nothing but v. So v is equal to u plus at. That is the derivation for first equation of motion. So instead of u, you can make it as v naught also. It becomes v minus v naught, which is nothing but v is equal to v naught plus at. Like that you can derive. Okay. While coming to second equation of motion. So what is second equation of motion? S is equal to ut plus half at square. How we can write this one? X is equal to v naught into t plus half at square, isn't it? Let us try to solve it. Okay, we know velocity. We know that velocity is nothing but displacement by time, isn't it? So if you take average velocity, then it becomes VAVG, average velocity. Whenever you find average, final minus initial. So x minus x naught, or we can make it as s minus s naught by t minus 0. So initial it will be 0, final it is t. Initial displacement is x naught, final displacement is x. So v is equal to x minus x naught by t minus 0. Now, okay, still if you don't want to get confused, what you can do, just simply you take this v is equal to x by t. That's more than enough. Okay, now another formula we know that VAVG, average velocity, not only this formula, we have another formula, that is sum of velocities by number of velocities. In your examination, if they ask what is your velocity, sorry, what is your average marks, what you will do in mathematics also, sum of terms upon number of terms, that is the formula for average. Now we have to go with average velocity, so same thing you relate. What is average velocity? Sum of velocities upon number of velocities. How many types of velocities we know? Only two types of velocities. Number one, initial velocity. Number two, final velocity. Now, so average velocity is sum of velocities. Initial velocity plus final velocity upon number of velocities. How many number of velocities we have? Two. So this is the formula. Okay, now this you take v is equal to x by t. Okay, now what we can do? Okay, here we got so average velocity is equal to this one. Now from this equation, v is equal to x into t, or velocity is equal to displacement by time. From this, displacement is nothing but velocity into time. Basic formula which you have studied in 9th class. Velocity is equal to displacement by time. From this, displacement is equal to set the time, that it becomes velocity into time. In this velocity, what you can do, you can substitute this. If you substitute, it becomes s is equal to, instead of v you can substitute u plus v by 2 time multiplied with time. Now we know that from first equation of motion, v is equal to u plus at. Substitute that v is equal to u plus at here. If you substitute, it becomes s is equal to u plus, this v is there, instead of v you can substitute u plus at upon 2 multiplied with time. Now it becomes what? S is equal to u plus u 2u plus at upon 2 multiplied with time. Now what you can do? You can take LCM. So S is equal to, here, this is one part, 2u by 2. 2u by 2. This t will be multiplied with t, plus this is another term, at by 2 multiplied with time, because this time is multiplying. So that now what happens? Numerator denominator 2 will be cancelled. S is equal to u into t, it is ut, plus here 2 is in denominator, take it aside, it becomes 1 by 2 a, t into t is t square. Like that you can derive second equation of motion, s is equal to ut plus half a t square. Now we need to derive third equation of motion, that is third equation of motion, v square minus u square is equal to 2 into a into s. Okay, we know, here I will do v is equal to u plus at. From this, send that u that side, it becomes v minus u is equal to a into t, right? Now, so, and also we have another formula. What formula? Average velocity. So what is average velocity formula? Here already we have seen this average velocity, u plus v by 2. Now, okay, here you see v is equal to u plus at. As we got, don't get confused here. U value is represented with v naught. Okay, average velocity into time is equal to displacement. Now you see this. Same, say what we are taking. Velocity is nothing but displacement by time. Basic formula from this, displacement is equal to velocity into time. Now this velocity we are taking it as average velocity. So it becomes what then? S is equal to average velocity u plus v by 2, sum of terms by number of terms, sum of velocities by number of velocities into t. Right. Now send that t and 2 that side. It becomes 2s by t is equal to u plus v. Right. U plus v. Now what we can do? Consider this is a first equation. This is second equation. Multiply first equation and second equation. So if you multiply, you see this one. Okay, this first equation let me write. At is equal to v minus u. This is first equation. Multiply first and second equation. These both will be multiplied at one side. These both will be multiplied at another side. So this can be written as u plus v into u plus v or v plus u, both are same, isn't it? So if I write 1 plus 2 or 2 plus 1, both are same. So this can be written as v plus u multiplied with v minus u, which is nothing but this 2s by t into at. Now t gets cancelled. Here it is in form like v plus u into v minus u, that is a plus b into a minus b, nothing but a square minus b square. So this is a plus b into a minus b, that is a square, v square minus u square is equal to 2 into a into s. Like that you can derive third equation of motion. So like this, three equations can be derived by using algebraic expression. And in our next lecture, let us see how to derive equations of motion using graphical method as well as calculus method. So watch these videos in order, and maybe after 1 day or 2 days I'm going to upload fourth lecture. Within 3-4 lectures, let us complete this chapter. After that, all the numerical problems related to every concept will be uploaded. So if you like this video, share this video to your friends. They too will learn, and don't miss these classes. Read regularly so that definitely you are going to gain 100% of knowledge. Till then, bye.